everybody to Global R&D of March 2023. So today is gonna be a historic day for ICP and Bitcoin. And before giving more spoilers here, let's look at our agenda that we have today. Next slide, please. Right, so I guess it's not only a historic day, I think it's a whole historic month because as I'm sure you all know, OpenChat has launched as an SNS this month, like just a few weeks ago. It feels like ages already, but we're still very proud on that, and Hamish will have all on that. And even more than that happened, there was also like FederItaly has brought ICP into the Italian Senate. And Emilio will tell us about this very nice event. And then next on, we're gonna slow down a little bit. So Ben and I will talk about ICRC proposals. Then we're gonna continue about the features. Deet will talk on Ethereum integration, what the plans there are and where we are with that. And then, well, I gave it away already a bit. Of course, we have to talk about ckBTC and the proposals that are coming up. So Manu will explain that. Then Nathan will talk about another nice ICP feature that is out now, the response verification, the next version. And then, as usual, we conclude with demos. We first have the community demo by AirGap. And then Andre will talk about Canister timers. So let's go and have it. So as said, first on will be OpenChat. And I'll give the floor here to Hamish. Again, warmest congratulations on this, what you guys pulled off. Yeah, let's have it. Thanks, Hamish.
Thank you, Jan. Yeah, so I will talk about the OpenChat SNS launch that we carried out a few weeks ago. We successfully raised our target of 1 million ICP, which is amazing. So I'll talk about why we did the sale, give some firsthand experience of how it has been since that sale, since the DAO launched, and finally just talk through some of the interesting proposals that we've seen so far. So next slide, please. So why did we decide to launch an SNS? So I'll just cover the main reasons here. The tokenization, in order to compete with the incumbent big chat services like WhatsApp and Signal, we need a way of really driving growth. And getting tokens into the hands of as many people as we can is a really good way to do that. Just we can algorithmically reward people, user rewards. We can give people referral rewards for them inviting friends and family. And this will just end up growing a massive user base who are basically just advocates for the service because they are all themselves literally invested in the service. And by tokenizing it allows us to reward people who contribute, whether that's through moderation or bug bounties, or people providing translations. And then another benefit of having decentralized service is the decentralized governance itself, where the service, it will be acting in the best interest of the community, whereas something like WhatsApp, it's owned by Meta, and so it will act in the best interest of Meta. But for us, for OpenChat will always act in the best interest of the community because it is owned by the community, and that's a massive benefit. And yeah, also the users are co-owners, so the users themselves just feel more like they're part of the system because they are more part of the system and they can drive the direction. And then the final reason that we launched the SNS was to raise funds, because OpenChat needs to be it needs to be able to run on its own. And so it needs to have funds to be able to cover its running costs. Also, a useful thing for those funds is we've been able to add liquidity to DEXs just to make the trading experience better for people, whether they want to buy or sell chat tokens. And also going forward, using the ICP we raised, we'll potentially be able to grow the team. So next slide. So yeah, how it's been since launch. Just after launch, a few days after launch, there was an issue where new SNS proposals weren't actually visible in OpenChat, and it made it really hard to pass the proposal with the fix because these SNS proposals weren't really visible anywhere. For example, the NNS DApp didn't have SNS proposals set up yet. So it was actually really hard to pass the fix. And at one point, the fix was on 49.999%, and we were trying to get it up to 50 to pass, but eventually we got there. Yeah, and second point, sometimes proposals have taken 4 days, which is a bit slow. Most of them we are able to get past in a quicker time because people are following us. But overall, it's been a really good experience, actually. It's been probably a lot easier than we thought it would be. It hasn't been that different to how it was before we launched the SNS. And yeah, next slide. So yeah, here are some key proposals that we've had so far. So this one, we announced a motion proposal we submitted a motion proposal to airdrop 1 million chat tokens to Diamond members. And this is a great way to grow our user base and grow a massive team of advocates for the service. And you can see from all of the reactions on here, this was by far our most wanted thing after the launch. People were calling for the airdrop, and that will be coming very soon. Next slide. Yeah, so this is something that's really cool that we can do now that we've launched the SNS. We can add liquidity to various dexes like ICP swap, Infinity swap, soon IC dex. That one's a bit harder because it's an order book, but we can add that liquidity from the treasury. So the funds will still be under control of the SNS, but they can be used by the community when trading, as in the community can trade against them just so they get better trading rates. And then final slide. So this one, we submitted a motion proposal to make a market maker canister, which we will use to autonomously place limit orders on IC DEX. So it's quite cool. It will be under the control of the SNS, but it will again make the market just so that it's people trading get a better experience. And yeah, that's all from me. I'll hand over to Bjorn. He's got some cool charts.
Yeah, thank you, Hamish. Yeah, so this is Bjorn. So I'm talking here as a community member, stakeholder of OpenChat. And one feature about the SNS framework, which I really like, is that it exposes a lot of interesting data on neurons, on transactions, on sale metrics, etc. And that allows me as a DAO member to verify what's going on. So I can audit the SNS setup. I can check to which degree, for example, OpenChat is decentralized. I can verify how the fundraising actually went. And what I want to do now is like to give you some insights on what kind of things you can do with like this data and how you access it. So here on that slide, I focus on like the tokens that were distributed at Genesis. Overall, 48 million tokens, chat tokens were distributed. You can see from the chart on the left-hand side that a bit less than half of these distributed tokens went to Def and Seed, and as marked in purple, and then the remainder went to green, direct sale participants, and yellow gold to the community fund. And we overall had more than 2,300 principals participating in the sale and 113 principals participating via the community fund. And if you want to check this yourself, I have give you on the bottom right hand side, you see an example how you can call DFX, for example, to get information on the direct participants. So you will get all the principals and the amounts that have been sort of put by these principals, and there are similar queries, for example, for the community fund participation. All right, so if you go to the next slide, please. You can also look into the governance. So if you will look at this nice graph here, so that's a neuron graph. So every node and that graph is a neuron, and the size of a node reflects the voting power. Color code is, as on the previous slide, purple, Def and Seed, gold, community fund, green, direct sale participants. And an edge in that graph means following. And this data was pulled 3 days after the Genesis OpenChat SNS. And what you see very nicely is like the structure of the basket neurons. So every sale participants received a basket of neurons, 5 neurons, and they all follow then the neuron in the basket with the longest dissolve delay. And that this appears as these little flowers here in that picture. And indirectly, you can also see from the picture that sort of some of the sale participants immediately after genesis increased the dissolve delay of their neurons already, which actually increased the voting power of the community, which now I think is like around 60%, which is very good. And now, like if you fast forward to the next slide, so 3 weeks after genesis, you see like the same neuron graph. And what you see here now is that clusters of following are emerging. So we have the beacon neuron from the left team, and you see quite a few neurons chose to follow the beacon neuron. There's a second cluster, at least a second cluster, and maybe more emerging. And I think it's going to be super interesting to sort of to monitor this over time and see like how the governance structure of OpenChat plays out and like the different players in the interaction. Again, if you want to verify and pull the data that underpins that graph, I have given like the DFX call on the bottom right-hand side. So essentially you're querying the governance canister of OpenChat here to list the all current neurons in the system. All right, yeah. So for me, as you can see, like that's super exciting, and I think it's a very useful tool for the participation in the SNS governance. Back to you, Jan.
Thanks, Björn and Hamish, and congratulations again. I was so happy to see that, and despite you wrecked a night of me, I guess more than one night, but the night where I was in the hotel at Denver, because this whole token swap was going on in the night in Denver, and was watching that. I don't think I slept more than half an hour in a piece, and bought some, like participated on and off in that thing, and was so happy for it to go well. The other big thing that happened one more big thing that happened in March was actually FederItaly brought ICP in front of the Italian Senate, which was also very exciting to see. Luckily, it happened during the day, European time. That was a bit more digestible for me. Emilio, tell us more.
Thank you, Jan. Hi, everyone. Hello, world. This is Emilio from the DFINITY marketing team and special projects manager. And today I'm going to briefly present what happened with the 100% Made in Italy brand certification. So in an effort to create 100% Made in Italy brand, DFINITY and the Internet Computer, of course, Origin Foundation, which is an app deployed on our ecosystem, and FederItaly, which is a non-profit organization strictly cooperating with Italian authorities, joined forces to create a certification hosted 100% on the Internet Computer blockchain. Why? Because we know that there's a lot of counterfeiting around, and not only that, don't just think about, fake luxury goods and stuff. There is a problem of what we call Italian sounding, which is companies that are completely legit, but abusing a little bit of this sort of Italianity around the world, when in fact, the product itself has nothing to do with it. How? Well, again, through a technological partner, which is Origin, thanks to the feature of the Internet Computer blockchain, and with the endorsements of the institution. Briefly, on this little infographic, you can see how it works. In the next slide, I'll explain a little bit more. So companies get strictly certified offline. Once they're certified offline, representatives of FederItaly will upload details in a pre-formatted form that will generate a QR code and an NFT that are given to the manufacturer, and it can be used on the products and for promotion. Consumers will be able to go to the supermarket, for example, in their favorite shops, and soon be able to scan a QR code and being directed on chain to verify the authenticity of the certification. Next slide, please. All right, what do we have here? This is a first trial of what the certificate will look like, and a little better explanation of the process. You see, first they get certified, then information gets uploaded. It's securely stored in a Canister smart contract. Smart contracts on the internet computer are called canisters for people that are attending for the first time. And then the QR code is generated together with the certificate as a NFT. Next slide, please. Here we are. So a little bit of experience, you can actually try it. You can scan this QR code and be directed on chain to try the sample of the certificate. That is the one you have seen before. All this is hosted on chain on a Canister, and the website, which will have the domain FederItaly.com, will be public. So user will be able to access the website and have a look at what companies are certified for real, have a little bit of experience and a little bit of a tour of the whole initiative. And at the same time, as a consumer, that will have guarantee that the product is genuine. Next slide. As you can see from this little patchwork here, this has generated quite a lot of buzz. There's pictures of myself and Paul Musen, VP of Finance, speaking at the Italian Senate, together with representatives of Origin and FederItaly. A few senators were present. Actually, the initiative was promoted by a senator and representative of different ministries, especially Made in Italy Ministry and Agricultural Ministry. As you can see, press and crypto press has supported massively. We got Yahoo Finance here, we got Cointelegraph, and we got Bloomberg. Few more are coming. I just got the news that another couple of big outlets will pick up the news. So let's wait for it. That's it. Back to Jan.
Thanks, Emilio. So I don't know, you probably have wondered what the ICRC is all about. Maybe you think, oh, it's somewhat related about the ledger ICRC1 being a popular topic on global R&D. But actually, it turns out it's about much more than that. And Ben Tsai will most likely surprise you in the next few minutes. Ben, thanks.
Thanks, Jan. This is Ben from the product team at DFINITY. And today I would like to introduce you to ICRC Proposals. As we all know, blockchain is all about interoperability and composability. In order to achieve that, we need to have standards on the platform in the similar fashion to ICRC1 for all aspects of the platform. So what we're proposing here is to formalize ICRC Proposals procedure so that this would be a community endeavor of the all developer community for new standards and features on the IC. ICRC Proposals will target application level of standards, although some of them would require protocol level changes, but that is outside of the scope of the ICRC. To this end, we have set up a GitHub repo. You can scan the QR code. And there's actually a link to the forum post. So we will be having a new catch-all working group session to discuss all pending issues of the ICRC GitHub repository. That will be held bi-weekly, Wednesday, 7 a.m. Europe time, starting 12th of April. This will be a coordinated effort so that developers will do less repetitive work, and in the end, their applications would have better composability. Next slide, please. So ICRCs are really a new dynamism in the ecosystem. Everyone is welcome to contribute by opening a new issue or pull request on the GitHub repo. The process would go roughly as follows. First, a proposal would be opened, and there will be discussions simultaneously on the forum or on the GitHub issue. Then the working group would discuss. It could go into one of the specific working groups, or it could be discussed in the catch-all working group. A draft proposal and rough consensus will be reached in the working group, and there will be code implementations for each of these proposals. Once that is done, the proposal will be sent through NNS for ratification purposes. The aim is for any proposal with reasonably generic use cases, so it's not something that's specific to your application, but it could be something that would be industry specific, so only for gaming applications or only for social applications. We aim to have an open process so that we can encourage creativity. So you're really open and welcome to open any proposals that you think has a reasonable chance of getting through the procedure. However, most of them probably would not go to. So if we take a comparison with Ethereum EIPs, you will see that approximately a quarter of all proposals are in the final or last call, which is close to final stage. And most proposals are remaining in draft or stale status because due to various reasons, adoption reasons, like completeness and a bunch of other reasons. So we aim to have a procedure that is similar to Ethereum EIPs and hope that there will be a lot of proposals and very interesting creative features that are proposed specifically for the IC. Next slide, please. So this is the QR code for the GitHub repo. Please scan the QR code now and please start this repo. So as you can see right now, we have set up this repo a couple of weeks ago, and up until today, there is already approximately 10 proposals that are quite well formulated. We haven't got around to discussing them yet, but this just shows how much enthusiasm there is in the community for this new ICRC procedure. And I hope, and it's a call to all the developers on the IC to think about what you could standardize and what would be beneficial in your industry. And we really welcome all use cases. So please do so, formulate your standards and participate in this construction of the ecosystem, because ultimately you are at the forefront of innovation on the IC. And it's really all the developers that were making a coordinated effort to really boost the ecosystem. So please scan the QR code, start the repo, send in your proposal, and I will see you all on April 12th. Thank you all.
Thanks, Ben. Let's move on to the upcoming new capabilities of ICP. And I mean, obviously, Bitcoin and Ethereum are the most important blockchains out there, and they have a lot of adoption. Maybe this, I mean, even so, they have severe limitations. And the goal of the foundation is to work on directly integrating with both of these chains so that, and maybe also other chains, to address the limitations these chains have and make the life of the developers of these chains easier and get them over to build on ICP. So Dieter, tell us more about how the community, the foundation together are working towards the integration of Ethereum.
Yes, thanks, Jan. Hello, everybody. Good morning, good afternoon, and good evening. Greetings from the 2023 Blockchain and Education Summit in Oxford, where I'm currently. I'm Dieter from the DFINITY Foundation, and it's really a pleasure for me to talk to you today about the Ethereum integration. So what is it about? It's about the direct integration of the internet computer with Ethereum. And this will be done in a trustless way, like Bitcoin, in the sense that no additional trust assumptions are required and no additional parties are required. So analogous to what we did for Bitcoin, so a strong model. Why are we doing that? So Jan already hinted at it. Ethereum is currently the world's largest smart contract blockchain in terms of market cap, DVL, daily DeFi volume. And also as a world computer, the internet computer now needs to integrate with those others and help those other blockchains. And we can get really nice use cases out of that. For example, think of ERC20 liquidity coming over to the IC. So for example, ERC, like chain key, Ether, chain key, USDT, chain key USDC, stablecoins, for example. This will be a massive boost for our DEXs. Or for example, think of ERC 721 NFCs on the IC, like chain key NFTs, or think of oracles for Ethereum that become possible via such an integration. So it's all very enticing use cases, and I think the creative mind will come up with many, many more. And how are we doing it? So this direct integration, this native integration in a trustless manner is a large project, and this would take many months to complete. For this reason, the community has asked us to take a two-phase approach, and I show this on the next slide. So the two phases are phase one, a short-term solution to bringing this Ethereum integration to the internet computer using HTTP outcalls to cloud API providers such as Infura, Chainstack, or Gateway FM. And this is built by the community, so there's also already something available, and DFINITY is going to help now to improve this and also enable it with IPv4 so that more API providers can be reached. So the whole idea of this phase one is to act as an enabler for the community to start building their dApps that integrate with Ethereum right now and not wait until the phase two is available. So it is a short-term solution. It has a weaker trust model than the full solution in phase two, but it's a very right thing to get done now so that people can start working on the nice dApps. And example use cases, as mentioned earlier, are chain key ERC20 tokens, which the community has already started building, I heard, and those will be built by the community or DFINITY, so still to be worked out. And the important thing is that the APIs of phase one and two will be very similar in the sense of it will be easy to migrate if you build your dApp on phase one to a phase two implementation once it's available. And phase two is this full native integration that we have already started working on, but this will take some time until it's complete. On the next slide, I'll motivate why it's important that we have one API. So I already mentioned there should be an easy migration path. If you build a dApp now based on the phase one implementation, it should be easy for you to migrate to the phase two implementation once available, because phase two is the more secure one and it's the thing for the long term. And because the architectures like phase one using HT outcalls, there will be a slight difference in APIs. For example, one needs to specify the max response size and, for example, the API provider in the phase one, which you don't need in the phase two. So phase two will have the simple API as shown here. So just giving an RPC call payload in and the chain ID and to get back a JSON RPC response, and that's it. So a very simple API. And on those APIs, we are currently working to refine them to the final state with the community, mainly with the DeFi community. So it's a very good collaboration. And I think it's really crucial to get the API right now so that we can have this smooth migration from phase one to phase two. On the next slide, I would like to talk briefly about blockchain integrations technical working group. So that's a new working group I launched recently. And the mission of this working group is to work on the roadmap and strategy, as well as do concrete technical work like API design for future blockchain integration. So it's very wide open, but currently, initially, it's focused clearly on the Ethereum integrations, both phase one and phase two, to get this done as quickly as we can together with the community. So that's a really great effort. The inaugural meeting, the first meeting was on March 22nd, and we had a strong attendance from the Chinese DeFi community. Here, many thanks to Herbert and Ben for the simultaneous interpretation efforts of the discussions between Chinese and English. This was very helpful. We had really great discussions and ideas there. And among other things, of course, we discussed Ethereum integration APIs for phase one and two. And also it was mentioned by the community that the community is already working on a chain key ERC20 token implementation. So now a shout out to everybody. If you're interested in Ethereum integration or general blockchain integrations, please join the working group and help define the future of the IC. So this is a very important topic. Some people called it the blockchain singularity working group. So really join it if you're interested in these topics, because everybody is welcome to participate, even if you're only an observer. And if you go to the next slide, you see the barcodes to scan in for related to this working group. And this is already it from my side. I would like to hand back over to Jan.
Thank you so much, Dieter. Yeah, next up is Manu, and I won't say anything more.
All right. Yeah. Hey, everybody. I'm Manu. after Dieter already talked about CK ERC20 tokens, we still are working on ckBTC. But first, I'm actually going to talk a little bit about tainted BTC. So Bitcoin and other cryptocurrencies are traceable, right? Because the ledger is public, so you can follow funds around exactly and look at their history. And now there is a term, tainted Bitcoin, which I put in quotes because it's a bit of a vague term. But so tainted Bitcoin refers to funds that have some bad history. So for example, maybe Bitcoin that comes from sanctioned entities or from dark web markets or mixers or stolen funds, things like that. And there are various companies that specialize in doing this analysis of the transactions that you see on the blockchain, and then giving like risk scores to transactions of what kind of maybe potentially bad exposure these funds have. So some companies are Chainalysis, Elliptic, TRM, and many others. And centralized exchanges often work with such companies, especially to check funds that are being deposited at the centralized exchange. And so they will not like it if you send Bitcoin there with a questionable history. And this relates to ckBTC because there is now some concern that one user, let's say user A, deposits such tainted Bitcoin into ckBTC and receives ckBTC for it, and now might sell that ckBTC to user B, and user B tries to redeem this Bitcoin and sell that maybe on a centralized exchange. But now the centralized exchange says, oh, this is, Bitcoin coming from questionable sources. We don't like that here. And the user might now have a hard time selling that Bitcoin on a centralized exchange. So this is a risk for ckBTC. And for this reason, we didn't propose yet to allow anybody to convert Bitcoin into ckBTC. And we've had a lot of discussion on how to address this. Next slide, please. So in this slide, you see the plan that we landed on with our internal discussions and discussions with the community. So what we will propose is to add a KYT canister. And KYT stands for Know Your Transaction, which is this transaction screening looking for tainted Bitcoin. So the flow to convert Bitcoin into ckBTC would be that the user sends Bitcoin to an address that is controlled by a canister on the internet computer. It waits a while for the confirmations to come in, and then the user says, look, ckBTC canister, I send you Bitcoin, please give me ckBTC for it. And now that ckBTC canister will reach out to this KYT canister to check the funds that have been sent in. And the KYT canister will do that by making HTTP out calls to Chainalysis. So they have this API, they specialize in this. So we ask them, what's the risk rating of these funds? And then if there's no risks, the ckBTC minter gives ckBTC to the user for the Bitcoin that was deposited. Next slide, please. Yeah, so the purpose of this is that now the pool of Bitcoin that backs the ckBTC consists only of clean Bitcoin, I guess, that users know they can sell at a centralized exchange. One challenge here is that these HTTP out calls to Chainalysis need to be authenticated, because Chainalysis is a company, they sell paid subscriptions to their service. So you cannot just make these calls for free. An extra challenge is that they cannot make like a contract with the internet computer itself, right? They need somebody to pay a bill at a time. They want some legal entity to work with them. So we need some entity to have such a subscription with Chainalysis that then can provide such an API key to this canister. And so the way we propose to do this is that the network nervous system who controls the KYT canister also controls a list of principals that can each set an API key. So these API keys are set by certain entities that took out such a Chainalysis subscription. And every time a request comes into the KYT canister, it picks a random one from the list of available API keys, to handle that request. And of course, these entities that insert these API keys, they need to be incentivized as well, right? Because they need to pay ahead of time for this service. So they will get rewarded in ckBTC every time their API key is successfully used. And so this will incur, we will propose a 2,000 Satoshi fee, which is like $50 US, to do this check every time you convert Bitcoin into ckBTC. And of course, this fee can change over time. It's controlled by the NNS. So if whatever the Bitcoin price goes up, or we see that nobody wants to do this, we might need to adjust the fee. Next slide, please. Okay, so yeah, this was a very lively debate, a lot of discussion on this. We really appreciate all the feedback from the community. And so with all this, we landed on the approach that I now sketched. So very concretely, we will submit 3 proposals very soon, hopefully today, might be tomorrow, to realize this architecture. So the first is that we propose to install this Chainalysis KYT canister. So that proposal allows you to just verify the source code and see that canister looks good. Then the second proposal adds such an initial list of principals that can provide API keys. And here we will propose Tonic's principal to be in that list. So Tonic is a company that builds on the internet computer. I guess they're known for Entrepot, the NFT marketplace. And they were willing to help ckBTC because they want to use this for other projects that they're planning. So they took out, or they will take out a Chainalysis subscription and then serve as the first API key provider here, and others are welcome to join, of course. That's the second proposal. And then the third proposal will be to upgrade the ckBTC Minter canister such that it uses this KYT canister. And then finally, anybody can convert Bitcoin into ckBTC. And we will reduce the required confirmations to 12, such that these conversions are a bit faster than they are now. But so with this, ckBTC will be fully functional and can be fully used. So these proposals will appear very soon, and I hope that everybody votes, and I hope people will vote yes, because yeah, I would be very happy to see this all used. I'll quickly answer one question. There's a question about, could this be under an SNS instead of an NNS? I think theoretically that's an option in the future, maybe. It's also quite complicated. There is actually some forum discussion going on to think about who could control this. So I'll try to put the link in the chat. But it's a very good question, and we're thinking about this. Next slide, please. So this is what we will be proposing now. I'll briefly touch on maybe a bit of the longer term vision. And so what we're proposing here is very much like, a first step. It works only with Chainalysis, which is just one party. But we do believe that, I guess, decentralized on-chain KYT can actually be a unique and valuable tool that internet computer canisters can take advantage of. I guess there's a lot of regulation and a lot of, I guess, more and more being cracked down on a lot of things like this. So having this option that you can use on chain might be very valuable. I guess the vision is that there could be multiple service providers instead of just Chainalysis. Maybe you can use some majority voting, like 2 out of 3 determine whether we accept things or not. And ideally, we would get service providers to either provide their services directly or on chain, or have many API key providers like we now have for Chainalysis. Yes, this is where we are. Look out for the proposals. They're going to come soon, and I hope you vote. And thanks, everybody, for your attention.
Thanks, Fanny. So all the Neuron holders out there, please get ready to vote and write history. So the final update here is on verification of responses. So, I mean, if you enter the URL of a smart contract on ICP, you want to be sure that all the answers you get are actually from that smart contracts, and that's where response verifications can help. And Nathan, please tell us how this all works.
Thanks, Jan. Hey, I'm Nathan, and I'm a software engineer on the trust team here at DFINITY. Today, I'd like to talk about response verification, what it is, the shortcomings of version 1, which is the current version, and what we're doing to improve it in version 2. In summary, response verification is an HTTP gateway subprotocol that verifies query calls made on behalf of an HTTP-aware client, such as a web browser. I'll talk more about what an HTTP gateway is shortly. In its current state, response verification is limited to verifying a response body with respect to the request URL. It's not possible to trust response status codes or headers, and the response body can only change if the request URL changes. Version 2 overcomes these limitations by allowing for more requests and response parameters to be included in the certification process. This will allow for canisters to perform redirects without using update calls, return varying responses in different languages on the same path, safely leverage cache headers, and many more use cases. On the next slide, I'll talk about what the HTTP Gateway Protocol is. The HTTP Gateway Protocol is an extension of the IC protocol that allows conventional HTTP clients, such as a web browser, to communicate with the IC network. It does this by providing a mechanism for translating between standard HTTP requests and IC canister calls. Implementations of the HTTP Gateway Protocol are known as HTTP gateways, but I will refer to them as just gateways. Existing gateways include the service worker and ICX proxy, but there will be more gateway implementations in the future. The service worker is a script downloaded into a browser that implements this protocol locally, while ICX proxy implements the protocol from a remote server. On the next slide, we can see how an HTTP request lifecycle looks. It begins with an end user, also known as an IC person, opening an internet computer app in their favorite browser. The web browser sends a standard HTTP request to a gateway. The gateway translates this request into a query call and forwards it to the corresponding canister on the IC network. All going well, the canister responds to the gateway verifies the response and then translates it into a standard HTTP response before returning it to the browser. Now the IC person can view the app in their browser like any other website. On the next slide, I'll talk about the difference between update and query calls. Query calls will mutate canister state, so they are handled by every replica on a subnet and go through consensus. This makes them secure, but slower than query calls. Query calls do not mutate canister state, so they do not go through consensus and are handled by only a single replica on a subnet. This makes them much faster than update calls, but since they do not go through consensus, a malicious replica could lie about the response. Response verification gives us the security of an update call with the performance of a query call. To do this, query call responses will include a certificate that is signed by all replicas on a subnet during the previous consensus round. This certificate can act as a proof that the responding replica is not lying about the response. On the next slide, I'll talk a bit more about this certificate. This diagram, which is pretty conceptual and not representative of the underlying implementation, so I'd encourage anyone curious about the technical details to go check out the spec. But this certificate is returned in the IC certificate header as part of a query call response. We can see a representation of this for version 1 in the top half of this diagram. In this case, the header maintains a proof that the response body hash is correct for the current request URL. On the bottom half of this diagram, we can see version 2 represented. All of the new pieces introduced are highlighted in cyan. A cell expression is introduced and returned in a new header called IC certificate expression. I'll talk more about that expression in a moment, but this cell expression can be used by canisters to dictate what request and response parameters are used when calculating hashes to be included in the certificate. And the certificate will now maintain a proof that the cell expression, request, and response hashes are all correct for the current request URL. For both versions, the gateway is able to extract all the necessary information from these headers and use it in combination with the public key of the IC network to verify the authenticity of the response. On the next slide, I'll talk more about the cell expression. So this expression allows canisters to determine what parameters will be included or excluded from a certificate. These parameters can now include not just the response body, but also the status code and headers, as well as the request method and query parameters. And all of them are optional. It's now possible to exclude the entire request or response hashes from the certificate in a certifiable way. The syntax of the cell expression is pretty simple, but it's flexible enough to allow developers to specify all of the parameters that I just mentioned. The cell expression itself is also included in certification, so the gateway can be sure that it really came from the canister. On the next slide, we can see an example. So here we have a cell expression and a visualization of the effect that this expression has on the calculation of request and response hashes. At the top left, we have representation of the query call response that includes the headers that we've discussed previously. At the bottom left, we can see the actual expression, and this expression allows a canister to perform a redirect in a certifiable way without using update calls. As we move to the right of the diagram, we can see the effect of this expression. The sections highlighted in cyan are those included in the hash calculation, and those highlighted in gray are excluded. Request hashing is skipped entirely, and the location header is included in the response hash. The status code and response body are always included by default, regardless of the cell expression, and the request URL will always be included in their certificate. But in this case, it's not included in the request hash. The request URL in the request hash will always be an exact match for the current request, but the request URL that precedes the cell expression in the certificate can include wildcards. So we can use this to our advantage and certify the redirect for any requests that do not match a more specific URL. And because the location header has been included, the gateway is able to certify that the redirect was intended by the canister. On the next slide, we'll talk about the main deliverable for this project. So we have developed and released a package which contains all of the common gateway logic required to implement both versions of response verification. This package is written in Rust, published to crates.io, and is being integrated into ICX proxy. It is also compiled to WebAssembly and integrated into the service worker with auto-generated JavaScript bindings. It may also be used by other gateways in the future, potentially through the use of foreign function interfaces, depending on the language that the gateway is written in. On the next slide, I'll talk about what's happening next. So the service worker will soon start respecting cache control headers for asset canisters supporting response verification version 2. And any canister that's using DFX simply needs to upgrade their version of DFX and redeploy their asset canister to be compatible with version 2. For anyone using custom asset canisters, we will be working on some libraries that developers can use to make the transition easier. We'll provide ample documentation and sample repos to help developers leverage certification to its full potential to improve the security and performance of their dApps. On the final slide, I have a few acknowledgements to make. We do also have a QR code here that will link to a forum post where this feature has been announced. There you can find links to the source code and the spec for anyone who wants to learn more or potentially provide alternative implementations of this protocol. And this would not have been possible without all of the individual contributors and teams mentioned here. Frederick, Daniel, Robin, and Joachim all played a huge role in getting the spec together. The security team did a very diligent review. The SDK team added support for response verification version 2 to the asset canister, and the trust team developed the response verification package. If anyone has any questions, now is the time to ask, or feel free to reach out on the forum afterwards.
Thank you, Nathan, and thank you to all the people that you have listed for making ICP even better. Yeah, but please ask questions on the chat, and we can take them from there. Not your key, not your crypto is probably the most important mantra in crypto. The flip side is losing your key is losing your crypto. And so actually, because living up to that mantra is maybe the most difficult thing in crypto, maybe second to understanding how all the cryptography works. And AirGap has set out to help here, and I'm very happy to have Nicholas today and to tell us how they can make our lives much easier. Nicholas, please.
My name is Nicholas. I'm one of the guys from AirGap. We are a cold wallet solution from Switzerland, and we have been around since 2017. And we are quite happy to announce that we have added support for ICP and ckBTC just fairly recently. And I will walk you through really quickly. So let's start with self-custody in general. So as you know, as Jan has already mentioned before, self-custody is quite hard because with great power comes great responsibility. If you lose the mnemonic, you also lose your funds. And you have to make sure that everything is secure and safe on the side. So there are, in total, are like 3 major challenges for users. First one is generating a secret. This gets done by using a random number, and having this random number is much more difficult than most people think. There's a chip, the random number generator, and some people have a bit of concerns there, how random it really is. Then secondly, we have the storage of a secret. As mentioned before, if you lose your secret, you have no longer access to your funds, and if somebody steals it as well. And last but not least is interacting with the secret. This should be as seamless as possible, of course. If it's like written on a steel plate and you always have to type down your mnemonic, that's quite annoying and is hindering you from interacting with the Web3. So as we can see here, there are like 2 sorts of wallets. They are like hot wallets on the left side, which is on the phone, which has great usability, but limited security because it's connected to the internet. And on the right side, we have a classical hardware wallet, which has fantastic security, but limited usability because you need a USB cable, you have like tiny buttons, and this can be quite hindering a bit. And we have decided to try to fit right in between those 2, find the sweet spot, and like take the advantage of the great usability of a smartphone and the fantastic security of a hardware wallet. And what we have come up with is, we thought like it should be possible to take the most battle test device and turn it into a cold wallet. And that is the smartphone. There are billions of smartphones out there. And we have created 2 applications in total. We have, and one of which is the AirGap Wallet, which is installed on a normal smartphone, and it turns it into a cold wallet by you turning off all your connectivity and allowing you to enjoy the great usability of a smartphone with its camera, with a big touch screen, etc., etc. The secret itself then gets also stored on the, now I'm blanking on the name, on the secure enclave on the device itself. This works on Android and iOS as well. As mentioned before, the application consists of 2 applications. On the left side, you can see the AirGap Wallet is installed on a dedicated offline device. And on the right side, you can see the AirGap Wallet, which is the watch-only wallet where you can initiate transactions and see how much money you have on it. Now, before we were talking about generating a secret, and I was talking a tiny bit about this random number generator, and we wanted to add an additional security on top of that. And that's why, apart from only the random number generator, we also use video, sound, gyroscope, and touch as additional sources of entropy. This will then look like this. So you record your surrounding, use touch, microphone, and so on and so forth. So we have total randomness. And let's talk about interaction with this solution. So everything works with QR codes, so-called transparent QR codes. So basically, you take your AirGap wallet, you initiate a transaction, it then creates a QR code, you take your vault, which is on an offline device, you scan it, you sign the transaction, and it then creates another QR code, which you then scan with your AirGap wallet. And then you just approve it and the transaction gets executed. So it's fairly simple and it can be done within a minute. And there are many more security features. We have BIP39 passphrases. Apart from our secret generation setup, we also support coin flip and dice rolls for giving the user more security. We also have multiple secret support. So you don't need like multiple devices. You can store all of them on one single device. And we also have social recovery, which is also known under the name Show Me Your Shares. Then we have, so if you want to update your offline device, there's quite a simple way. You can download the APK for Android, put it on an SD card, locate the APK on the device, on your offline device, and install it. And that's quite straightforward. For iOS, we do not have a solution there yet, but we are working on something that will enable exactly the same mechanism as well. As mentioned before, we now support ICP and also ckBTC. We also support other currencies, such as the classic Bitcoin, Ethereum, etc., etc. Our solution is open source. It's completely free to use. It's reproducible on Android, of course, and it's Swiss-made and exists since 2017. And I'm quite excited to also mention that one thing that is coming up probably next week, I hope our developers are finishing it up before Easter. We will soon include ICP staking, so you can store your coins really, really safely and at the same time get rewards, which is a big plus. And yes, that's it. This is our solution. We offer strong security and fantastic usability. Thank you.
Thanks, Nicholas. So great to see this. And finally, I know what I can do with my old phone. Now, next up is something I'm also very, very happy to see. And I'm judging from all the activities on the forums, I'm sure a ton of people out there are also very happy to see that. And without further ado, Andrew, the floor is yours.
Thanks, Jan. Hey, everyone. My name is Andrew. I'm from runtime team at DFINITY. And today I'm going to update you on the Canister timers feature. The problem we are trying to solve is to automatically execute Canister smart contracts. Simply put, the internet computer should be able to call canisters periodically with an interval. For example, a canister does an HTTP out call to update the exchange rate every 15 minutes. Also there should be a way to automatically execute the canister just once. For example, a canister starts sales at the specific day and time. Well, I imagine there are tons of use cases, so it was one of the most requested features by the community. And by the way, if you ever wondered how to request an improvement or to meet other developers and DFINITY engineers, just go to the forum DFINITY.org. We are all there. So to recap, from the very beginning, from the genesis, the internet computer is actually able to execute Canister smart contracts periodically. The feature is called heartbeats. Heartbeats worked fine and continue to work just fine. There are many production solutions built on that. It's just the heartbeat interval is short. It's about 1 second. And there is no way to adjust the interval or pause. Because of that, heartbeats are just too expensive for many, many use cases. So DFINITY engineers, together with the community, came up with the following solution. For backward compatibility, we keep the current heartbeat functionality as is, and then, based on our heartbeats experience and real use cases, we implement a new functionality called Canister timers. The protocol level changes are really tiny. There is just one new system API call implementing a single one-shot timer, single per canister. The rest of the functionality is in the CDK, the Canister development kit. There are CDK timer libraries for Motoko and Rust. Each library implements multiple and periodic timers. The interface is quite intuitive and familiar from other platforms. And as a side note, it's a cool approach to separate the implementation on the kind of protocol and library levels. Because when we change the protocol implementation, it's a breaking change. But when we change the library, it doesn't break existing running in production Canister. So it's a cool approach to implement it this way. Okay, on the next slide, please, there is a feature status. The Canister timers are generally available. It means basically that it's all done. And I guess it's not a surprise for many of you because the functionality has been available for early adopters since December. Just in those 3 months, timers made it into many internal and community projects. Just to name a few: OpenChat, Bitcoin integration, ckBTC, ASIL, and many, many more. On the tiny graph, there is a number of timer invocations per second for the past month. I deliberately squeezed the graph a bit so it's easier to see the trend. And while it's still early days for the timers, the usage has been doubled for the past month, which is quite cool. Okay, what was exactly done? The IC interface specification is updated, protocol changes implemented, deployed on all the computer subnets. There are Rust and Motoko CDK timer libraries available for the developers. Since it's a developer-facing feature, there is also a little bit of paperwork. There are examples, documentation both for Rust and Motoko. Also, you can play with the timers locally using the DFX, our SDK, or you can play with the timers online using Motoko Playground. Yeah, so basically that's what was done. Of course, it was an effort of many teams at DFINITY to deliver the Canister timers. So thanks a lot, everyone involved from the SDK, language, testing, verification team, runtime execution teams. And of course, thank you, the IC community, for providing your feedback and helping us to improve. The next slide, please, is just to show how easy it is to use the timers. As you can see, I managed to fit 2 examples in one slide, so it's really easy. Actually, it's the same functionality implemented for Rust on the left, Motoko on the right. So basically, high level, there are just 2 steps. First, we add the timers library, and then we just create a new timer with the specified minimum interval or timeout. In this example, the ring function will be called automatically by the internal computer every 5 seconds. So if you are not using timers yet, I hope you are convinced by now. So the last slide, please, is to help you to get started. You can scan the QR code or just Google this document. It will take you from basically 0 to hero with timers. And if you have questions, just ask on the forum. We listen. And at the end, I just wanted to share a bit of my personal feelings. I think timers is a great example of community suggestion being materialized into an actual implementation. Knowing that it's a highly anticipated feature, people at DFINITY were very excited to work on that. And basically, I'm excited to see how you are going to use timers in your project. Thanks again, everyone. We did it together. And back to you, Jan.
Thanks, Andrei, and thanks to everybody presenting today and for all the great work that was behind, went into all of these things. It's really amazing to see, and Could be more happy. Well, maybe I'm even more happy. I'm happier if all of you join us again in 4 weeks from now for the next public global R&D on April 26th. See you all there. Thanks, everybody. Have a good rest of the day.